All right, so I think this is class number 3. Is this number 3? Okay, good. And today, as I mentioned before, is Java Bootcamp. Bootcamp for Java. We're going to do everything. We're going to learn everything you needed to know about Java in about 2 hours. 2 hours and 45 minutes at the maximum. Let's see how far we get. I'm going to have the assumption that you've already programmed in some language before. If you haven't, get a basic for Java programming book. This is the Android class, but we need to know a little bit about Java to get started. So go ahead and open up Eclipse if you have a computer and you're ready to go. So I'm not going to do a PowerPoint for this. I'm just going to run through a bunch of stuff. And I've been doing Objective-C all weekend, so my brain is thinking Objective-C, so I need to switch gears to Java, so this is good anyway. So this will be interesting. Let's create an Android project. So we're going to go File, New, and slow me down if I go too fast, because some of your systems run a little bit slower than mine. Not bragging about my system or anything, but you know my computer's pretty fast. All right, so New File. Why did they go File New? I'm sorry. Android Application Project. If you don't see that in the list, it's under Other. Android Application Project. And I'm going to call this Java Bootcamp. Or Java Bootcamp. There we go. Because I'm going to save it and upload it with the video that I'm recording right now. For those of you who are having problems, you get lost, your program is not working. I don't know what I'm going to do, but by the end of what I'm doing, you'll have the finished copy. So, all right, leave it all on the defaults. Leave it on whatever you have. Doesn't really matter. Click on Next. Click on Next again. Click on Next again. Click on Next again. Main activity is good. Everything's good. Just click on Finish. And they should just have a quick, end button right there in the beginning. I just want to create a blank project. So you get this that comes up. So, and in here, it took me a few minutes actually for mine to actually populate. I got a little blank screen that says Java Bootcamp on it. I'm going to add a label. Well, I'm going to add a text label to my GUI because it just happens to be here right now. Unless you want to use System Console, where you go System Out, Print Line, it goes to System Console. This is an Android app. All of our output is going to the view, and the view is connected to this activity that we just created. So I'm going to write some code in the activity and show you what I'm doing, and then we're going to put the output onto our view. For the purposes of simplifying, because this is a Java overview, for simplicity's sakes, drag a large text or a text view. Take a text view, actually, it's easier to remember. Take a text view, drag it onto your canvas. Put it underneath Hello World if you want. And stretch it out. Notice it won't stretch out. Okay, just leave it alone then. I'm gonna remove Hello World actually. I'm gonna click on Hello World and remove it. And then I'll just leave my text view. Or actually, if you want, you can put some text in it. I'm going to put in here some text to start with. So I got some text to start with. This is my output screen. So it doesn't really matter what it looks like or what it is. Just put something out there. We're going to print results out there. All right. And we're just going to use one text view. It doesn't really matter. Have we gotten this far?
What are we supposed to do on this side?
Drag a text view, stick it on your canvas,
Yes.
and you're done. You're done. Drag a text view, stick it on your canvas. The ID of your text view by default is going to be text view 1. Leave it alone, because then you'll remember what it is. It'll match mine. I'm leaving it at text view 1. Did we get this far? We're good. Okay, save it. So close the little tab that says activity underscore main has been modified. You want to save it? Sure, I want to save it. Yes. We're done with the GUI. We're not doing GUI today. We're just done with the GUI right now. We got a text view. That's going to hold our output when we start doing stuff. Okay. Go back up to the beginning of the project files on the top and open up your source code directory. And click on main-activity.java. Or double click on it to open it up in the right hand pane here. So our output for this activity is on that main activity view, or activity underscore main XML file, where we dragged and dropped and put that text view out there. That's what's here. So that's activity underscore main. Leave all that stuff. We're going to leave all the existing code alone. And I'm going to talk about Java. We're going to make a Java class. We'll make an instance of the Java class, and we'll have the output go to that text view is what we're going to do. So this is the main starting point for your Android application. You get it by default when we created a brand new project. Most people just leave it alone and leave it as main. It's main. So in Java, we have files that start out with the same name as each one of our class objects is stored in a separate file, and it's the name of the class that's inside of the file. This one's called main activity, and the file is called mainActivity.java. So now we're going to create a person object. So click on the package, whatever you called your package is right above, inside of the source code directory, src directory, we have the package. Go up to File, select New, and instead of doing, because we're not doing a project anymore, we're going to add a class object. Select Class. It's the second item down underneath Package. Select Class. All classes in Java must start with a capital letter, and they must be saved in the same file as the name of the class that's defined inside of it. So type in P for person, ERSON dot, or actually you don't need to put the .java in there. You'll get an error if you try to do that. Just type in person. Unselect, we don't need a public static void main. We're not creating a console application. We already have main. The main is going to be our main activity that we're running. All that stuff's set up for us automatically. We don't even have to worry about that. Instead, unselect these guys. Unselect everything down here actually, and then click Finished. You do that, now I see a person class. So by default, all classes are public. You have public, private, and protected. Public means it's open to main. Main activity is our main. We didn't put main in here, and we deselected that option. If you did, just erase it. You want this to show up on the screen, or this should be on your screen right now. And this is a class, just like this one's a class. So I've left the two tabs open so I can show you back and forth what we're looking at. We're going to create a brand new class. So we always start out public class. This is actually optional. You'll see some source code on the internet that just says class person. By default, it's public. But it's always a good standard just to put it in there. So leave it in there. Public class. Over here we have a class that's extending another class. I'm going to talk about that in a few minutes because we're going to make an employee who's a person. We'll extend, and I'll show you the inheritance. And believe it or not, I'm going to go through the entire core Java in about 2 hours and 45 minutes. If it's too fast, don't worry about it. This is not meant to go at this speed. This is because some people know Java, some people have a little review. This is a review, so this is brand new to some people. If it's brand new for you, I guarantee it's going to be way too fast for you. But let's just see what happens. So we have a class out here called person.java. If we go out to our workspace directory, we'll see that saved actually in there. So the definition of the class has 3 components: identity, state, and behavior. The identity of this class is person. It's a person. Its states are going to be the data that it's holding on to. And the behaviors are what the person can do. Can the person grow? Can the person shrink? Can the person walk, talk? All those little activities that the person can do. So I follow a very C++ kind of format with this because I'm also a C++ person. And actually it doesn't even go, it goes back to C, where we always put our data member, we always put a data at the top of the program, and then we put functions underneath it, and then we put function prototypes on the top if you're a C person. Java, you're lucky. There's only one file. There's no prototypes of anything. Everything gets put into a Java file. There's no interface, separate interface file. It's all in one. So I'm going to give my person some information. I'm going to type in string name. And then hopefully I'm not going to get any red squiggly lines, and name's going to show up in blue. So all my data variables show up in blue. My comments are green. Errors are in red. You don't want to see red. Blue's good. And I'm going to go integer age. Let's just give him an age, and I don't know what else the person needs. String Name and age sound pretty good to me. When we make a new instance of this object, and let's go ahead and make a new instance now, we're not going to make it inside of the class object. We're going to make it inside of main. Main's called a driver program, and you make all of your objects, and then you create instances of those objects inside of main. So I'm going to save this guy. I'm going to close the little window to save changes. Close the tab. I'm back out here in main. Next week I'm going to do the lifecycle stuff. I was going to do the lifecycle stuff this week, but then I kind of had a last minute idea of doing this Java stuff today, so save the lifecycle questions for next week. But on create is the first visible part of the lifecycle. It creates the view for us. Let's make an instance of that object. And so if I make an instance of that object called person, I type in person. So for those people who don't have a programming background at all, it's a data type space object reference. And so just like I said, integer age and string name, I declared two variables. I'm going to make an object instance by going person, and I'm going to give it a name, my person. I'm going to say my person 1. And that's going to be equal to a new person. And I'm putting in an opening and closing function called bracket looking thingy bob. Opening and closing, what do you call those things? They hold parameters, but I don't have any parameters. And for those of you who know what you're doing so far, we just used a default constructor actually to make this. So now I have a reference to an object called person. It's actually my person 1. And so in other object-oriented languages, I go my person 1 dot something, my person 1 do this, do that. And then I have these behaviors. Well, I don't really have any behaviors yet, but I want to show you constructors first. I created this one using what was called a default constructor, but I don't actually have a default constructor, and I have no constructors. So we have this thing called a constructor. The constructor is a behavior, but it's a special kind of one. It's not really a method. They call it a constructor because it only invokes at one point when you make a new instance of the object. Until you make an instance of the object, constructor never triggers. So, which is kind of interesting. When I made that new instance, if I were to print out the information associated with a name and an age, it would be blank. It would be null because I haven't initialized anything yet. So if I create a constructor, which is what I'm going to do, it has the same name as the class name, and it does not have a return type. So I type in person, and then I have an opening and closing. It kind of looks like what I just ran, kind of in opposite order. I have an open set of brackets in there. And inside here, I'd put some code to initialize those variables that I just created. And the variables I just created were name and age. So I'd go, let's say name is equal to unknown, maybe, because we don't know who that name is. And then age would be equal to 0, maybe. Make them 0. Did I spell unknown correctly? Yeah, I did. So I wouldn't have, at this point I'd have like, okay, well, I don't know who this person is because they didn't give me a name. So if I wanted to make a new instance of a person and I wanted to provide it with a name and an age, then I could make another constructor. So I can have as many of these as I want. And this is going to be way too much information for you, but this is what's called constructor overloading. So I can have one that says integer age, perhaps. And then I can have one that says, and what I'm doing here is I'm accepting what's called a parameter. And the parameter that I'm accepting here is just the age. I could have one that said name. I could have one that says name and age. But let me show you a little trick. Now, stop typing if you're typing all this stuff in, because it's not gonna. This is gonna save you some time. Okay, so if I'm gonna remove everything here. I'm gonna go up to source. Right, I'm gonna let Eclipse do it for me. I'm gonna go up to source. I clicked on source. So click where you want to put the constructors. I want to put them right here. Click on source and come down to where it says generate constructors using fields. We got that? No? click where you want to remove all that stuff you just put in. So you have string name and integer age. You got that far? Hit on source. So you're opening up the source menu. Go down to generate constructors using fields. Press, select it. We have two fields. The fields are the data members. They call them fields in Java. It's really variables or data members. Name and age are both selected. And so let's see. If public or if default is selected, that's fine. Generate constructor comments, we don't need that. Omit call to default constructor super, we don't need that, we'll leave it alone. Just press OK. Oh, I didn't get all of them. Let's see, hold on a second. Oh, I got it because I selected both. Alright, so I had both of those items selected, so I put the first one there. Let me do it again. And I'm going to say generate constructors using fields. And this time I'm not going to select any of them. I deselected both of them. And I selected OK. Now I have the default constructor. I'll explain super in a few minutes. I like to put the default one on top, and then underneath it, I'll put the one that has everything. And then underneath that, I'll put the two different combinations. So I have one that takes both, one that takes none, and one takes the age, and the other one takes the name. I thought there used to be an option to do them all in all the different combinations, but it could just be me. So I got one for name. I'm going to create one. And you might ask yourself, well, why am I creating all these? These are all the different ways that you can create a person. And these are all the different things that you could pass to it when you create the person. Now on the default up here, you see this super. Java's funny. On Java, as opposed to Objective-C, as opposed to C, well, actually, it doesn't really matter. I'm not going to compare different languages today. We're extending from object, but we don't have to tell anything about that. So all thing that we create, all the classes that we create are extensions of object as a concept. But we don't have to explicitly say that we're extending object. When we extend, we inherit from. So that's the keyword extend that's being used in Java to represent inheritance. We also have implements. I'm not going to get into that today. I'll wait till later before I do interfaces with Java. But it's implicit that we're going from object, and object is super. We're this, and what's above us is super. So when we put super in here, which is actually kind of optional, we could press that little option there and not put super in there. It's going to initialize our super object first, and then it's going to initialize our code. So if you wanted to put the initialization back in, and you wanted to do it more formally, we could say this.name is equal to unknown. Because it's really our name, and we're this, but we don't have anybody else in the hierarchy at this point. So we could have just said name is equal to, like I did before, but it would be better to say this, like this.age is going to be equal to 0. This.name is going to be equal to something. And you see the compiler has done it for us automatically down here. So this.name is going to be equal to the name that we take in on the command line when we create the instance of that object, and then age is going to be the age that's going to be in here. Same thing you get with other programming languages. If you know another programming language outside of Java, you're in better shape actually, because it's the same kind of pattern. Some languages use self. Java uses this. Everybody uses super. But in C++, you'd super back, and you'd put the parameters inside a super. You don't in Java. Although you can, you don't have to. So you could just call the super default constructor. But let's not worry about that. I'm not going to give you everything there is to know about Java. I can't possibly do that all in one lecture. But just enough to get started with Android, what you're going to need for Android. So leave the supers in when you see the supers that are created for you. Over here with the person, we got the name is equal to name, age is equal to name. But we don't have, in here, we have the age is equal to 0. In Java, you're lucky. Data is actually automatically initialized to its default value. So a name would be empty string, and an age would be 0. So all integers and numbers are initialized automatically to 0. And strings are empty, characters are empty, space character. Which is actually good because you're never going to get an error message. In C, C++, if you said integer I and you used I before you assigned a value to it, it would come up with an error message. Not in Java. Java's better that way. So just take that at face value. We've created a person. The data in our person is private. Our class is public. So private means it's only visible inside of this class. So if I were to come back out to our main program, and now I have my person1, and if I were to type in my person1 dot name is equal to something like hello, I don't know, just put something in there. I'm going to get a message. Oop, it's not giving me a message. Okay, I'm supposed to be getting a message because by default I believe it was private. But maybe it's public in this instance. Well, let's see. Oh, now I'm doing C++. I don't want to do that. Private string. Now I'm doing Java. We have this access modifier. Let me do it this way, actually. If I go a private string name, private integer age, and let me save it so it knows what I'm doing here, because it's not out of it. I'm trying to produce an error message. If I come out here in main, now I got my error message. My error message, if I hover my mouse over it, it's going to say, the field person.name is not visible. So private makes it visible only inside of the current class object. If you try to use it like this, I've tried to use it. I made an instance called person1 and I did a .name and I tried to use it outside of the class. It's in my main class. It's actually in main activity.java. It's not visible. If I changed it around and said public, it now is visible. I'd have to save it first. The error message goes away. Where are we going here? Save, 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 save. Now the error message goes away because now I can touch it. That's not very safe. Not safe at all. Because now I can just change the name of any one of these objects without following any rules or anything. I can just go ahead and go in and change and do whatever I want to that data. Might affect the integrity of the class. So what you're supposed to do by default is make this data private. Make the data private. Make all of the member functions, which you see public in front of all of these constructors that we created, because we haven't really done anything else yet. Make all the member functions public. And then use what they call setters and getters. Some textbooks call them accessors and modifiers. Some of them call them other names. I call them setters and getters. Java calls them setters and getters. Objective-C doesn't call them that. But anyway, and you might think to yourself, well, why do I want that? Let me show you how to create them automatically for you. The beauty of Eclipse is that you really don't have to know very much about Java to use it, because the Eclipse is going to do it for you. Half of what we're going to do in class we can do without knowing Java, but it's nice to know what you're doing. So I'm going to go up to source again, and there's another button here that says generate setters and getters. And here it is right here. Generate getters and setters. I said it backwards. Getters and setters. So if I generate getters and setters, and I do it for both, so I click on age, and I want name, and I leave it on public. So this is the access modifiers. Remember, we want to make these methods public. If we put them on default, I believe we get public by default. And now it looks like the data is public by default as well, but it used to be private by default. I pressed OK. Now you can probably see why I'm calling these setters and getters. Get name, set name, get age, set age. That's where the getters and the setters terminology comes from. So set name takes a name, takes this dot name, makes it equal to name. Get name returns a name. Oops, here it is up here. Get age is going to return the age. Set age is going to take an age and it's going to set this dot age to age. So I use the setters and the getters out here in main because now I got this private message all over again. If I say let me show you how to run a method. I want to set this name because I use the default constructor up here. And I didn't set a name. And the name's going to be unknown right now. I'm going to set this, I'm going to make my person number 1 to Larry, Curly, and Mo. I'm going to make 3 of them. I got the 3 students going on here. So I'm going to have my person number 1 dot set name. So I type in the name of the method and then I give it a parameter. And the parameter it wants is a string for name. So this is going to be Larry. So we got Larry. So now person number 1 is called Larry. Now I'm going to create person number 2, which is going to be Curly, and I'm going to make Curly 50. I could do this. I can go like this and go, let's make this guy, I don't know, how old is Larry? Isn't one of them older than the other one? Let's set age to, what am I going to give this? I'm going to make them all 50 years old. They're probably 100 by now. 3 students. Alright, so I got Larry, I'm going to make Larry 40. I'll make Curly 50 and Mo 60. There we go. Mo's getting ready to retire. So now I'm going to have person, in fact if I wanted to I could actually, here let's do it this one here. Let's just do it this way. I got Larry. And I'm going to change my person to Larry. Now I got a pretty good example going on here. So at least people that download this example later will have something interesting to look at. So I'm going to go person Curly. How do you spell Curly? Is that Curly? Curly. Well, that's how Curly's going to be spelled today. It's going to be equal to a new person. And this time I'm going to set Curly because I want to exercise these other constructors. So I'm going to use the other one that uses both. So I'm going to set Curly to, the name is Curly. Curly. I think there's 2 R's. I think there's 2 R's in Curly. 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 And Curly's going to be 50. And I capitalized the N in new, which is wrong, so I'm going to lowercase that one. Now I got person Curly. So I've created another person, and the next person, Curly, that I created has 2 parameters that I passed to it through the constructor. This saved me a couple lines of code. So instead of having this, all 3 lines here do the same thing that this line of code does, which is why we have all these constructors. Because what if we want to do it all in one shot? You don't have to have all of these different options, but know that they're available to you. So now I'm going to do the other one. I think I have one that does, well, I've actually done both of them. I'm going to do it the fast way for the other one too. So person Mo is going to be equal to a new person. And that new person is going to be called Mo, and they're going to be 60. Whoops. And you have to put a comma in between the 2 parameters. So now I got Larry, Curly, and Mo. And I got a pretty good, decent running program here, I think. I'm not quite sure. And I've got a single object. And I'm going to leave this alone now. And I'm going to show you what this up here means, this extends thing means. So we have a base object in Android called activity. We have activities, services, broadcast receivers, a bunch of these different things. An activity shows a view to the user and allows us to manipulate the view. That's all activity does. It's the generic kind of Android application. So you say, what kind of application did you create? I created an activity. So, okay. You can create a view controller. You can create a bunch of other things too. And I'm going to go through all those in the coming weeks. But activity is activity. So this main class here, this public class main activity, extends, which means it's inherited from activity, which means it gets all of the things that belong to activity, plus it gets this stuff. And this stuff is nothing really, because this stuff is a overridden method on the onCreate and an overridden one on the onCreate's menu. I don't like that. I'm going to pull this one out actually. I don't really need that one in there. It's going to complicate. Not really going to complicate, it's just I'm not using it. So overriding and overloading. I'm going to show you that actually in a few minutes. So if I extend an employee, so I got a person object. I want to show you how to do this outside of Android, and what I'm doing is this is core Java. This is outside of Android, but it works inside of Android. Android is written in core Java, so it's using that. I'm going to close the person just to get rid of my real estate, and I'm going to save it. It says person has been modified. Would you like to save it? Say yes. I'm going to close the main activity so I don't get any confusion here. Save it. Say yes. So far so good. I don't have any error messages. Let's extend person. So person's we're going to make a new class called employee. And we'll make one of our people, actually we could just make some employees. We'll see how the employees can be made, and each employee is a person. So I'm going to come back up here and say file, new, and I'm going to say class. And so in here, I'm going to say that I've got, the name of the class is going to be called employee. So I'm going to type in employee. I'm going to keep it public. And where it says super class, I'm no longer coming from Java laying object. Instead, I'm going to put the word person in here. Person's my next, because person comes from Java laying language object. Person was inherited by object by default. If I don't inherit from anybody else, I come from object. So I got object, I got person, now I'm going to put employee. So employee is going to be inherited from person. So I'm going to put the word person in here, make sure you capitalize it. It's the name of the class that I'm extending. So I'm going to say finish. Now I come in here and I look at the file that was opened up called employee.java, and I've got public class employee that extends person. That's all we did with the activity. So if we wanted to create another activity, we did this in Hello World, by the way. I would come up here. I'm going to do it right now, and then I'll delete it. So you don't necessarily have to do it. If I come up here and go File, New, and I want to do class again, well, actually, I can't do it that way because I want to do it from the Android SDKs, which is a different hierarchy. I actually have to add an activity. And I add an activity is what we did last time. So we go File, New, and then we go Other, and we come down here and we say Android Activity. If I said Android Activity, and I say Next, and I say Blank Activity, yada yada, and I put it in here, then I'm going to get another activity that's going to be added to this class. And the activity that's going to be added to the class looks like this one here, this main activity. Looks the same as what I just put in, except for it has this it'll have some overridden methods, actually. And we'll see that as we build more Android-related projects in the future. But what I'm trying to do is explain this to you. This extends. So employee extends person. So I'm going to give this person an ID that's going to be an employee ID. So I'm going to add a member to this, and I'm going to say integer ID. So I added a field, actually, for an ID. All employees are people. So every employee that I make is going to have a name and age, plus it's going to have an ID. People only have name and age. Employees have the ID as well. So I can do the same thing as before. I can come up here and I can say source, and then I can say, well, let's create a constructor from superclass. So the constructors from the superclass. Well, what's super? Person. Because think one level above. So if I look at the options, I've got person, I got person int, I got person string int, I got person string. I got all these things. So I'm going to say okay, and I'm going to make them public. And I'm going to put them after ID as the insertion point. I just leave it on the defaults. And if I press OK, then I see this super doesn't do anything. This super here sends the age up. So I can create an employee, and then it takes on the age, and super gets the age. And then this one has string name and integer age, and I'm going to send name and age up there. And then this one just is going to have string, and I'm going to send super string up there. And I'm looking at here, well, what about the ID? Well, I'm going to do this manually, actually, so you can sort of see what this is all about. I'm going to copy this guy here that says, because this one's close, this is string name and integer age. That's going to send up name and age up to person. But I want to set that ID. I could use the menu options. I'll show you that in a few minutes, but let me just show you manually because this is a little slower. It's easier to comprehend. If I put a comma in here and put in here integer, ID as an example, I can get rid of this comment. Don't need the comment. But then I can say this dot ID is equal to ID. So I can set the ID, but before I set the ID, I'm going to set the super, which has got the name and the age, and then I'm going to give me an ID. So just because I create them generically through the automated system, I created a constructor stub, an entry point where I can just go ahead and modify it now. So up here, if I wanted to, let's say, I can set employee doesn't have anything to do here. I can just set this dot ID is equal to 0, maybe. Doesn't have an ID. Or unless I don't know, I could get into static, but I'm not going to do that right now. I'm not going to get into class level stuff today. Here I can just, leave the ID alone. It's going to be 0 anyway, so it doesn't really matter. But I can mix and match and add a few things to this as well. So in here, I've got to pass the ID, and then I can also come up here and say, well, what about my setters and getters? Maybe I'll just set the IDs. So I'm going to come up here into source, and I'm going to do the same thing as I did before and generate setters and getters and setters. And I'm going to do it for the ID. I'm doing this for a reason because I want to show you that we can set the name and we can set the age using the person stuff, setters and getters, because that's really part of the, but it's part of the employee. So I'm going to create a setter and a getter for ID. So I'm going to press OK. And then lo and behold, I have a get ID, set ID that I have down here. So I'm going to save this guy because I'm going to modify my main, and I want to make sure everything's up to date. So I'm going to go back to main. Now I created Larry, Curly, and Mo, and they're a big old happy family down here. We'll just leave them alone. I want to create some employees now. So I'm going to say employee now instead of person. Employee, and let's see, what am I going to call this? Bob. Bob works for every company. It's going to be equal to a new employee. And Bob is going to be called Bob. And, oops, there we go. And how old is Bob? Bob's a young guy. Bob's 35. And what's Bob's ID? 200? 200 sounds good to me. All right. So now I got Bob. But I created an employee. So the name and the age come from person. So I don't have to reinvent the wheel. I just add stuff to it. And if I don't like what I've got, I can change it. So I can, so I have Bob, employee number 1, Bob, and I've reused, the reason why we have inheritance is so we can reuse functionality that is in our base class. And our base class here is person, and our person has a name and age. Let's put a method in person. Another method, we looked at these constructors and these setters and getters and everything, but let's just put something for fun in here. I'm going to call this one public void grow. And grow is not going to take on any parameters at all. It's void. It's not going to return anything, but it's going to age. So I'm going to go age ++. You know C++, you know what that means. It's just incrementing. Grow is going to increment me by 1 because I'm growing. Or maybe I should call it age. I don't know. Called it grow. Maybe, you know what? I'm going to actually do something different here. I'm going to have some significant growth. Age plus 50. Plus equals 50. Plus equals says age plus 50. But right, why do you want to repeat age plus age? So you go age plus equals 50. It's a shorthand. Yeah, it's a shorthand. Huh? It's just like going a plus plus, age plus plus, or age minus minus. If you don't like that, type this. Type in age is equal to age plus 50. Both lines mean the same thing. Here, we'll take this one out. I keep forgetting. I don't know who my audience is, really. Okay, age is equal to age plus 50. All right, here we go. That's a person. That's how a person grows. So I'm going to close this guy out here. And then out here, in my main activity, let's make Larry's the youngest, so let's make Larry grow. So if I wanted to do that, I go Larry dot grow. Now we just aged poor Larry. He's now 50 years older. He's growing. So I want to say, well, if you're an employee and you're not a person, I don't want you to grow at the same rate. Because you're healthy, you're out, you're doing stuff, you're active. You're not just sitting on the couch watching TV all day, you're working for a living, you're going to live longer, right? So I'm going to go and click on employee, and I'm going to write the same grow method over again. But let me show you something. I still have grow out here, so I can go bob.grow. Because I put it in person and employee is a person and Bob's an employee, Bob can grow as well. Everybody can grow. So I'm going to go back to employee, and I'm going to put, actually, you know what, I'm going to shortchange it here. I'm going to double click on person. I'm going to copy out this grow function here, and I'm going to paste it into the other one. I'm going to put it inside of employee. So I've copied it from person so I don't have to type. And I'm inside of employee now, and I'm just going to stick it, I'll stick it on the bottom. So now I got the same method that I stuck in here. And now I'm going to go, well, I wanted to override it. So if I click on the little thing over here, it says the field person.age is not visible. And the field person.age is not visible because I'm going age and age. If I were C++, I could make friends. And that's a bad habit, actually. And this is really bad. So then other people do this. They go, well, what about this? Make it public and then you go super.age. That's bad practice, too. But don't we have something to get the age and to set the age? So we could run set age and get age. So we can actually do this if we wanted to. We can go this dot set age and then make it equal to get age plus, let's make this guy, how old do we want to make this guy? We don't want to make him, we don't want him to age as much. Age plus 10. Or if I wanted to be proper, I could actually go this dot get age. I can get it from the object, this. That's one way of doing it. Don't worry about it. We don't have to do it this way. But that's just one option of doing it. A lot of people don't know that they can actually do that. So this set age, what I did is I nested it. Forget about that part for a second. I said this dot set age, because this has a set age, and I'm not trying to go outside of it. In C++, we do this totally differently. But I can do this because it's part of who I am. I'm also a person. Because I extended person, I get access to it. But I can't touch the data. So if you're going to protect the data, you're going to run the setters and the getters, bottom line, point taken. So this dot get age plus 10, I'm setting the age to what I'm getting plus 10.
Get age.
Oh, I'm not ID, I'm sorry. I misspelled it, age. Of course, I could set it to the ID plus 10 and then it'd be 210 or something like that. But yeah, thank you. Thank you.
This is not equal to that age plus or equal to 50, plus equal to 50 is not equal to this.
Age, you know, you can't set the age. You can't touch age because age is private. Age is private over in person. The other thing you can do is make age protected. So,
Make it private. That's why I think I
Yeah. Well, I'm truly trying to demonstrate a point, so hold on. I'm not sure I would do this. I don't have to do it this way. I could go back to person. Oh, I'm in person now. Here we go. I can go back to person and change this private up here and make it protected. Actually, I don't know why I made them both protected, but I made them both protected now. So now if I go over here, a class that inherits from another class, it's now public to them. So now if I wanted to, and I'm just going to comment out this line of code, I'll just leave it alone. Now I can say age plus hello plus equals 10. And the compiler will be just happy with it. Most people would do this over this. This is a little convoluted, a little nested, and as you notice, I put in get ID instead of age. It leads itself to mistakes. If I'm talking about the age, I can just plus equals age. And that's why we use protected, because protection makes it so that it's still private to main. Main still can't touch it. But if I'm inheriting from person, and hold on one second, I just want to finish my thought. If I'm inheriting from person and I want to be able to control the person and I'm an employee, then it's protected in the fact that I'm giving inherited classes access to it, but I'm still not going to let main touch it. So this is the better approach. You do the same thing in C++, except for C++, you can have it say private and make it a friend. Violates the rules completely. So don't make friends with C++. All right. On that note, we'll break for attendance. Let's resume. So because I changed it, now it's protected. It's visible inside of employee. Oops, I was inside of person. So now I'm inside of employee. Now I'm inside of employee. And down here on the bottom, I can say age plus equals 10. And I can get that. And I'm going to leave this commented here just to show you that both of them actually work. In fact, if I do this, then I'm going to overwrite what I just did and add another 10 to it. So I only wanted to increase it by 10, so I'll just only do it once. Leave it right here. So now, although I've done something correct, I have this little green thing here. And this little green thing, if I press on it, what would happen? Minus. Well, let me undo it. Can I undo it? I can't undo it. Well, the little green thing was trying to tell me that I was overwriting something. I'm overwriting something because I have the same method in 2 times. I have one in person and I have one in employee. This is what they call overriding. It's not overwriting. So it's ride, not write. Which is the same message you get over here where it says @override. @override says there is a method inside of activity that's called onCreate. And super.onCreate, this might look a little bit more familiar to you at this point, maybe, is being passed saved this instance state. And saved instance state, you just have to take this for granted right now. It's whatever's happening on your phone. It's the instance, it's the memory. When you open up the app and you leave the app and you go somewhere else, there's a state that's saved. That's what's happened. So when you come back to the app and it gets created again, it's going to pull out that instance, which is the information. What screen were you on? What did you have selected? What data did you populate it with? And repopulate it and restore it. It's almost like it saves a cookie file. And that little file, it's not called a cookie file, it's called an instance state. And it's it's a bundle, which is a data type that represents, with lack of better words, it's kind of like a cookie. And it takes the bundle and it opens it back up and restores everything so you're back to where you were before, which is the reason why cookies were used to begin with. It saves information that the user was using. It saves the instance state. But long story short, super is activity. And in this case, we're running super dot, which means we're running the dot of super to onCreate. So I could say that I've overridden this because onCreate exists on super and it also exists in main activity. Just like over here, we overloaded. Oh, now my green thing's back. If you put the thing over the green thing, it says it overrides person.grow. So if I'm a employee, I'm going to grow by 10. If I'm a person over here, I'm going to grow by 50. So I've changed the rules around a little bit to see what happens. So what happens over here is when main activity super opens up, it gives us the window. Inside of the window, we want our activity to run. So that's why we set the context view. We load in our XML file, which is the activity underscore XML. Gives us our initial view that we created. We have one right now. We dragged and dropped a text box in it. We have the view. And then all this other stuff is what we've been playing with today. So we're actually building an Android app using Java in pieces. So let's figure out how we're going to do that. So we have a couple of different features now of, maybe I should grow here. Actually, Bob's growing. I already put the grow in. That's good. Okay, good. As soon as we do attendance, I've lost my entire train of thought. So I'm slowly trying to get back here. So we have a couple features. We don't have a console window. Normally at this point in my programming, I'd want to see, well, what are things happening? What's going on with this program now? What if I get the name? I want to make sure Bob's set correctly. How old is Bob, and how old is everything? So I can go back here and use a feature of Android, and the feature of Android I'm going to use is called the DDMS. The DDMS, if you click on this little thing up here, this little box up here, click on it. You see the second one down says DDMS, Dalvik Debugger or something or other. Don't quote me on what it's called. I always call it the DDMS. I click on the DDMS and press OK. I get this little window that comes up. And the window is coming up and it's showing my emulator in here because I've got my VirtualBox emulator loaded in the background. If you don't have your VirtualBox emulator loaded, load it now. Load it now and run your script to connect it. Or start your Android emulator. We're going to run this project in a few minutes. So if you get it ready ahead of time, you don't have to worry about it loading on the fly. But in here I have this thing called a console. Right now I don't have anything running. So my console window is empty. So what I'm going to do is create what's called a log. And I'm going to give the log an identifier. And then I'm going to look on the identifier to see all these messages. And I'm going to do similar to what's called a system out or a printf or a cout in whatever language you're working with. And I'm going to print a little note to myself so I know I got that far and who everybody's name is. You're not going to do this in a deployed Android app because there's no console. This is how we're going to debug our Android app. So that I'm going to also introducing you to the debugging tools at the same time. So over here you see you're stuck on DDMS. And this is a common problem. Actually, I've seen this on the internet. It's actually kind of funny. How do I get Java back? You close this down, it comes back up. Close it down. You can't get out of this screen. It's stuck. Oh my God. And then if you don't look over here, or if you remove this over here, you don't know that you can actually change the view from the window. And what you're doing is you're changing the perspective. So you can show open perspective. So what we did was we opened up a perspective called the DDMS. There's a debug mode, there's a Java mode, there's a resource mode. Or you can simply click on this little button that says Java next to it. And it takes you back to the Java mode. So these are different perspectives. We can switch back and forth. Or you can simply go back to here and then, well, actually here's Java default. Java default shows up in here too. So don't worry, if you close it down, you bring it back up, it's going to take you back to DDMS. You can get out, you just have to find the perspective for Java that you're looking for. So let's write a message to the console. We'll write a filter, and you'll see how the log works. So I got some information here, I got some strings and stuff like that. So I'm going to say log, capital L-O-G, which is an object, dot I, because I want to create an identifier that I'm going to use. And I'm going to open bracket here. I'm going to call this one test. Let's just call it test. Comma, and then I'm going to put some text here. And the text that I'm going to put here, let's just get a name. Let's say Larry, let's say Bob. Bob.getName. Because he returns a string, and I don't have to do any string conversion. And I got this little ugly little red kind of thing under here. So I'm going to put my mouse over here, and it's going to tell me I need to import the utility. And the import utility I'm doing is android.util. It's the log, L-O-G. And if I click on this first option, it says import log. Come up to the top. I open up my little things here. Now I say I got android.util.log. that was added to my package. So now I have test. You can put anything you want in there. Remember what you put in here though, because we're going to go back over to the DDMS. Well, actually, let's run it first. And then we're going to go over to the DDMS and I'm going to show you how to find it. So now, if you've got your debugger set, go ahead, click on your project, right mouse click, run your project, and run it as an Android application. And it's going to ask me to save these resources. I'm going to say OK. And it's going to bring up my application over here, hopefully. Oh, nope, it's going to tell me where I want to bring it up first. Okay, I'm going to bring it up over here. And I see the console. The console isn't giving me any help at all. In fact, the console gives me a bunch of negative feedback, in my opinion. Doesn't look too pretty. If I click over here, I've got my some text to start with. I haven't written anything to the output yet, so I don't have anything in there. But I see that my program is running. So I'm going to click back and I'm going to go to the DDMS. And if I go to the DDMS and I click on this thing that says Logcat, Logcat is the tab next to the console. I come back and I see this ugly negative reinforcement screen again that has all of the red messages about how my debugger isn't compatible with this and that. I really just don't care about it, so I'm going to close the window completely. So now I have my Logcat. My Logcat's got a bunch of stuff in here, and again I'm thinking, what do I care about all this? Ignored this, ignored that. Oh my god. I need to create a filter. I just want to see what I want to see. So I'm going to create a filter. I'm going to click on this little plus symbol over here. It says Saved Filters. And I'm going to click on the little plus here. I'm going to give my filter a name. I'm going to call it My Filter. And remember the tag I told you to remember? I gave it an identifier. I called mine test. You want to put the log tag. So by log tag, I tagged it with the word test as the identifier. And press OK. And lo and behold, over here, I see Bob showed up on the bottom. I got me. What is all this other stuff? Let me clear this out, actually. I ran this a couple of times, it looks like. You might just have Bob. You should just have Bob showing up. Yeah. Let's take a look here. Clear the log. I'm going to clear my log. I was testing this the other day with something else that I had running. So I had me and some bunch of other stuff. You should just hear. You should just see the word. So if I you don't have to do this. I'm just going to do this because I want to reset. I'm just going to run her again. Oh, bummer. Hold on a second. Alright, because I cleared it, it's going to clear it. Do you see the word test? Or, excuse me, do you see the word Bob in there? Because the guy's name is Bob. You didn't see Bob? You didn't see Bob. Let's see. Close the debugger. Let's just troubleshoot this a little bit. You have this line of code in there. It says log.i, and we have test, and then we have bob.getName. Okay, so, and you close your, if it's running in your emulator, close your emulator. It's kind of important to make sure this is in here because this is how we're going to check the, we're gonna check the status of everything. Make sure it's not running. Make sure that you've got this in here. So you want log I. Whatever you put in here is case sensitive. Remember what you put in there. And then comma get Bob get name. And then you could actually here, I'm going to put another one in here too. I'm going to put one in here just to make this more interesting. We have a Mo. I'm going to get Mo's name too. And then I'm going to run it. So run as Android application. Save the changes. Say OK. It started running. It has to be running. If it's not running yet, you're not going to log it yet. It's not going to show up in the log. So it's got to be running. Open up the DDMS clean again. Pull up the bottom screen here. And if you created the filter, it might be here. It actually showed me 2. I have to click on the filter in order for it to actually show. Everybody see it? Anyone having a problem with it? Okay, hold on a second. Let me pause this for a second, because this is kind of... All right, so hopefully you've got your logs working. If not, you're going to have to load your emulator, unload your emulator, unload your system, load your system back up, figure out how to do it. This is definitely an area, if you're going to get into this type of development, you have to develop some really good troubleshooting skills. Long story short. Because what ends up happening, and plus the more you work with this, the more you see the common scenarios. So anyway, and this is part of your troubleshooting exercise for today, is figure out how to use the log. You can also log just simple messages without an identifier by using log, and there's a couple of different methods and forms for log as well. And as we go through the course, I'll be showing you different features of the debugger as well. I'm going to flip back to Java. And so now I'm back in here. I printed out Mo's name and I printed out Bob's name. And now what I want to do is kind of figure out, well, let's see. Actually, now I have to get back on track because I took too long of a break here. I got person, I got employee, I got this grow method. So now I can exercise and see, well, what if I grow an employee, or what if I grow a person? I can test to see if one of them is going to be incremented by 50, if one of them is going to be incremented by 10, if I wanted to. You can go through that on your own. This is stuff that you can do on your own. I could print out the age. I could, you know, do a bunch of stuff here. I encourage you to play with this to kind of get a feel for the functionality. The only way you're going to actually learn this is to sort of experiment with it. Let's see, what else could we do? Well, let's write to that text box that's out there. So remember, we put a little text box out there, and I got a little piece of code I'm going to cut and paste actually, because there we go. You don't have this. Instead, I'm going to save myself some typing. And I'm going to do this here, actually. This is the piece I want. So, give me 2 seconds here. Close this project. Back to source. Go back into main. Alright, so I have a text view. It was called text view, I believe it, text view 1 out there. And it's sitting out there. And I'm going to say, well, I don't like to put it on the log message. I want to put Bob's name out on, I'm going to put Bob's name out on the text view. So up here on the top, remember what we did with person, we did with employees. At the top, we added the data members, and we created variables or data members, and then down here we manipulated it. So over here in the main activity, up here at the top, I'm going to add a text view. I'm going to call it text. We actually did this in the Hello World, but this is going to be called text view. It is a text view data type, and I'm going to call it oh, I don't know, name. I'll call it name. And that was going to be text view name, and I put a semicolon here. And if I put my mouse over here, it's going to tell me, can I import the text view of the Android widget? I'm going to say OK. So now here up on the top, I have Android.widget. Did I resume this? Yeah, I think I did. .text view. So now I just created a variable. If I want to, I can actually put up here, I could have put here, let's say, employee, another one. If I do that, you're going to say, well, what happened with that? Oh, nothing. You know, I just got another one. I'm making a reference to an object. Down here, I did person space Larry is equal to new person. This is actually the reference creation. This is the allocation of the object to an object type. I can mix and match these as well, as long as they're in the same hierarchy. So up here I said employee, another one. Down here I can actually say another one is going to be equal to, let's give it a person. New person, actually. I have to put the word new person in there. And let's just see what happened. I have to go the other direction. Add cast to employee. Yeah, there we go. I can add a cast to take, because I'm going the wrong direction. I can create a person. It's better to create a person and then do a new employee from a person into a person to go upcast instead of downcast. If I'm going to go downcast, then I have to explicitly cast. This is what's referred to as a cast. It's called a CAST. It's a cast. In other languages, we do it to do type conversions from float to double to string. We do this with objects as well. So I could do, let's say, for example, employee Bob. I don't know, we already have Bob. Peeps is equal to new employee. And I haven't done any cast at all because I don't have to. I'm creating a new employee and I'm assigning it to a reference type that I've created that's called Peeps. That's an employee type, which is what I did up here. I'm going to take this off just to make it clear. So up here I said employee, and down here, if I actually make this a person reference type, I don't need this cast, but I can still cast it. So what we have is a hierarchy of objects. I have an employee that can be anything that's within the same family tree can be of any type within the same family tree. It's called an ISA relationship. And up is to go up the hierarchy to object. So if I'm an employee, I can go up to person, and from person I can go up to object. It's basically following my supers. It's called an upcast. There's a downcast, but it's not good because every person may not necessarily be referenced as an employee if they were created as a person, because then you're going to have if you do an explicit cast to a person, make it an employee, which is what we're doing here, that's kind of unsafe because we made a person and we referenced it as a person and we're going to cast it as an employee. And you're saying like, there's nothing wrong here. It's going to tell me this is unused actually. It's going to say the value of the local variable is not used. Yeah, okay, so that's a really good message, but it's not telling me I've done an unsafe cast either. So normally we make references and we make objects of the same data type, but we could change this around here and say new person. We're going to take a new person and then we're going to cast it to an employee. Why are we going to do that? Well, if we want to make like data types, I can treat a person like an employee. I can treat an employee like a person, vice versa, by casting it, was the point I'm trying to make, actually. But anyway, know that you can also reference it. I'm going to take this out because we don't really need it. You can reference it up here. If I reference it up here, the scope of this reference is throughout the entire object. If I reference it in here, the scope is inside the onCreate method. So it's like what happens in a function stays in a function kind of thing. This happens to be onCreate, which happens to be main. So you get a whole breed of people that would put the name up here to give it a global scope, or they just put it in here. If I were to put it in here, then I could all put it in one line right here actually. I can go here, paste, and I can put, oops, I didn't paste in what I wanted to paste in. I can put in text view. I'll just make another one, text view, capital V. I'm a terrible typist. Text view, my output, I'll just call it output, equals something. Well, what's going to be equal to? It's going to be equal to another text view. So because I'm a terrible typist, I'm going to come back up here and repaste that back in here, cut and paste it, so I don't have to type this by scratch. This is the line I want to type. And voila, I'm a perfect typist. So I've got all in one shot. I did text view, called the text view output, and that was going to be equal to this.find by ID r.id text view 1. I went over this with hello world just to refresh your memory. This is the ID. If we go back, I know it's been a while, but if we go back into our resource directory and we go into our layouts and we click on the activity _ main layout that we created, first thing we did is we put this text box out here. And in the text box, notice it says @ ID text view 1. That's the ID tag, the ID property. And we can pull it out in over here by going from the resource.id. And it doesn't really matter what it is. It's going to be a text box. It's a text view 1. Comes back in, and now that's the reason why I was showing you casting. We cast it with objects. Everything's an object in the language. We're casting this object to a text view and making it a referenced object. So I could do this. I could put the output down here, and then up here, actually here it is, output. Output. I can also reference it, and now the error message, I can also reference it a couple of times if I want to. I can say, well, if I want, because it's just a variable that I'm using here. So I can go like this and say, well, let's call this 2, and this is going to be a text view. So I've kind of mixed and matched it a little bit. I've got now 2 references. I've got output 2 and output that are both pointing to this text view 1. So now I can set the text of this out view to something. So I can set it to, well, what is this here? Instead of writing it to the log, I can do this. I can go output dot set text, and set text is right here, and then put that method call in there because the method call is returning text, and it's going to be bob dot get name. And Eclipse is trying to help me by putting in all this auto stuff. So I have a reference to text view. It's called text view 1. And in there, I have a output local variable that I've created that equals the text view. This, we know this is this object, and find view by ID. This view that we're looking at. And now I can refer to it in my source code as output. Well, I can also do this. I can say, well, I'm going to do it again. Output 2 dot set text. And this one's going to be mo dot get name. And I'm going to quickly run into a problem because I only have one text field. And, oops, put in an extra bracket there. And the first one's going to overwrite the second one. And then I look at this and I go, well, how come this one's in blue and this one's not in blue? So the reason why I like to put them up here is because now they're members of this object, and this object happens to be called main activity, and it's a class member. This is a local variable. So it looks different. I should unclick it so yeah, there we go. It doesn't have the same kind of thing. So if I wanted to make it a class variable, it doesn't really matter. But if you make it a class data member of the class and you put it up here, then it's a member of the class instead of this temporary makeshift reference that you created that you're going to use. It's just, they both do the same thing. In fact, I can go like this and go output 2 if I want to and just string it up here and then pull out this reference down here. And lo and behold, now I have everything looking consistently, you know, blue. Not that blue is my favorite color, and actually green is, but it looks, you know, more easier to find. It's now a member. It's a data member. So remember I went back and I said, it originally started out saying that objects have 3 components, identity, state, and behavior. This is part of the state of the object. So if I put it up here, then I can easily find it, easily reference it in here. It's a member of the object versus a temporary makeshift. So yeah, a couple of different schools of thought on it. I'm going to actually put another text field out here because I only have one text field and I'm using it all over again. So instead I'm going to come over here, go back to my activity view. I'm going to drag another one. This one I'm going to put a large text. I'm going to drag this large text out over here. So I got a small text and then I got a large text. And my large text is called text view 2 out here. So then I'm going to come over here to the main view. And I'm going to say, well, what's this? I'm just going to change the 1 to a 2. So now I got text view 2 out here. And I'm going to say, well, what's wrong with this? Let's see what the problem is. And it's going to say, text view 2 can't be resolved, or it is not a field. I'm going to say, yeah, it is. Yeah, it is. In order for me to update R, however, I got to save the project. So some of you are having problems with R. Either you have the project opened up multiple times, which I actually saw in some of your computers there, or you haven't saved anything in about an hour or so. and nothing has been written. So in order for me to resolve this little error message here, I'm pretty confident all I have to do is really just save this sucker. Because I see it here, it says text view 2. I'm going to save it. If I save it, and I come back in and I go, whoa, it's gone. It's a miracle. No more problems. It's all done. Some of you who have had stuff dragged into the project, some of you who have multiple windows opened up, you have the same file opened up 5 times, you've only saved it once, but you've edited it in 5 different windows. My best recommendation is save it all. If the problem didn't go away, come up here to project and clean it. Clean the project out, and hopefully you'll have a better, hopefully all the R problems will go away. R gets automatically generated, synced up. It only syncs up on a save. So now if I run the program, well, what's going to happen here? I got output 2. The big one's going to show Mo, and the little one's going to show Bob. So let's test it out, see if it works. So I come back over here, and let me run this project. And it's going to say, you modified it, you want to save it? I say, yeah, I want to save it. And it's going to say, the project contains an error, please fix it first. All right, so let's go back in and see what the error is. And here's another interesting problem. And I actually kind of expected this to happen. And I kind of went, because I know that, okay, so the second to the back row, this is your problem. So I took, remember a few minutes ago I said I didn't want to type. And I cut and pasted something in, and I stuck it from one project and I stuck it into another project because I didn't want to type it. So now Eclipse has done something to my injustice. It has created, I have 2 different packages. I have this little thing up here on the top. It says import com.example.ja.r. And I'm thinking, where'd that come from? It automatically thought, because remember down here I pasted this in because I said I didn't want to type this. I wanted, you know, and it's from this project up here actually, and I pulled it from another source. It's unfortunate that it does this, and it shouldn't do this. It's actually sort of a bug. It's a problem. Take it out. If you paste something in, you drag, you drop, you stick something in there, you're going to get bad packages added to the top. Never, ever, 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 ever edit the r.java file. That's not the source of the problem. Leave that alone. Look to the top of the project. Take out any miscellaneous packages that could have been added. Problem is you can have more than one package inside of each one of your classes. Eclipse tries to think ahead for you because you cut it from this package and you pasted it into this package. You must want this other package too. No, I don't want this other package. So I removed it. Now I'm going to save it. If I save it, the error goes away. If you cut and paste off of the internet, if you cut and paste from one project to another project, if you drag code from a project or from a file on your desktop, you get the problem, go up to the top, make sure you have the correct package listed, remove any other unassociated r.java, anything that's red, remove it. If you didn't put it there, it doesn't belong. Okay, so now I'm going to run it. And when I run it this time, it should work, actually. So I'm going to wait for the little screen to come up. And I don't know if you guys in the back actually heard what I just said, but that would fix your problem. Remove the unnecessary packages that are listed at the top of your files, because it came in automatically through the system. It was nothing you did. So anyway, now I have Bob and I have Mo printed on my lovely little screen. And you might be wondering, why are we looking at Java today? All you're doing in Android is 100% Java coding. You're writing Java source code. Has nothing to do with this GUI stuff. You just put GUI stuff out there, and you tell the GUI stuff, put me here, put that there. You use it like variables. So going back to the project, we can make this a little bit more intense. We could go to a database, we could pull information out, we could do an internet search, we could pull information out, and we could stuff it into labels, into list boxes, into multiple select boxes. We could fill out a whole form of information. We can populate the entire screen with images and stuff. which is what we're going to do. Not right now. We're not going to do all that stuff right now, but watch what we're doing throughout the next 13 or 14 more weeks of this class. The basis of it, however, is creating the objects and using objects and creating instances of the objects, and then making sure, and then actually the one thing to keep in mind is if I click on the DDMS, I should see now double from the 2 times. And you saw me do it before. If you want to clear it, there's a button over here with a little red thing to clear the log, to get rid of it. Because sometimes, you know, it might be working, and then you might break it. And then you might load it up again and see this in here and go, yeah, it's still working. But it's not working because that's left over from the last time you ran it. And believe it or not, you close down Eclipse completely. You bring the Eclipse back up again, and lo and behold, the log is still here. Because it wants you to take breaks, go to lunch, and come back, and then, you know, everything's still there. Everything is still loaded. All right. So in the area of Java programming, and what else can I show you? Let's see. The things that show up with the @ symbol that are in gray, and it's getting kind of loud in here. Oh, whistling works. These are optional. If I take the little optional things out, you see I have the green thing next to it. There's a school of people, in fact, there's a menu option. You can put all of the overrides in there. Remember in my person object, or my employee object, I overrode it, the grow method, and it put this little thing in here, and it didn't put the @ symbol in there. I just took the @ symbol off of there. The @ symbol that said override, I took it off of there. I can do what's called overloading as well. If I overload it, and now that I've gotten this overridden, what you can do is you can make it a person, and then you can make an employee. You can grow them, and then you can print them out. If you have this working already, you're going to see your output on your text fields that you just created. If not, you're going to see them in the log down below. You can play around at this point, actually, and grow them. You can also do this, and what we're now going to do is what's called overloading. So this is overloaded. It already existed. Excuse me, we're going to override. What we did before was overload. It already existed. We ran the current one, but then we created a new one. So long story short, we can hide what was there, or we can complement what was there and give it a new thing. So as an example, if employee had, let's say salary, what is salary going to have that we could possibly change an employee? Well, if we're a person, we could have a method, maybe, I'll just create something down here, public. I'm going to show you another form of overloading. So overloading is complementing and adding another method to it. If I'm an employee, I get a different one. Then it's hidden. It's actually not overridden. Other languages, if you use the same method name with the same number of parameters, it's overwritten. And then you put the word virtual in there, and then it's overloaded. Depends on the dynamic creation of the object type in terms of which method you're going to get. In Java, it's actually overloaded because Java is 100% dynamic. It's who am I referencing you as in terms of which we have two. You got two. You got both the grows from person and you got both the grows from employee. You cast the employee to a person, you're going to get the person's grow. Put them in, you make them in a, you use them as an employee, you get the employee's grow. You actually once hidden until you change the reference. We can also do this. So we have employee, we have public void get tall. So we're going to make the person get tall, and we don't have a height, do we? Instead, I'm just going to go log.I, and I'm going to put a little guy in here for test. Here's the other thing. So I use test as the identifier for log. If I wanted to keep multiple categories, I could say, for example, in this one I can say in person, which means I put this log inside of the person method, and in the person method I'm going to put a little screen here. Then I'm not going to actually bother writing it to the text field. Instead, I'm just going to put it in here. I'm going to say got taller by 1 foot. So the person grew 1 foot taller. If I hover my mouse over this little message and say import log from Android util, the little message goes away. Now I get tall. So now I say, well, I want to overload this, but I want to keep get tall. I can do this. Over an employee, I can say, actually, let me do this. I'm going to cut and paste. Copy and paste. Copy. I'm going to add another method over here, but I'm going to change what's called the signature of the method. So I'm going to paste it in here. And in here, I'm going to say integer h for height. So then I can make the person grow by a particular height. And in here, if I had a height, I can add a height to employee maybe. I don't know. Or I can just say, you know, it grew. So over here, I've got both. I got get tall, and I've got get tall that takes on an integer. Now I have two methods that are visible inside of employee because they have different signatures to them. This one hid the first one. This one hid the first one because I'm in an employee. Person's hidden. It's now changed to employee unless I cast back to person. This one exists along with the get tall. So what they teach you in C programming and they teach you in basic and visual basic, never repeat the same function twice. You can't use the same name. Well, here we can do it again. I can go public void get tall with two integers, integer A and integer B. And if I spelt void correct, I'd be in better shape. And then here, this is one that takes on two integers. So they're all called get call. But we have one that takes on one integer, and I could probably increase the height by 1. This is going to increase it by 2, by 3. I don't know, the example's kind of makeshift right now, but long story short, this is another way of what's called overloading. So I'm overloading. I'm not replacing. I'm complementing. So we overload the onCreate to complement the existing app that we have loaded up, to add our new view to it, to put some stuff on the view, to do some stuff with it. So it's a term that you're going to hear over and over again. So if here I can say, let me just complete this, copy this, paste it. And this one here, in person is my new tag that I'm using, but I'm not. I'm in employee, so I'm going to say in emp. I have to remember this actually. In emp. I'm probably going to forget what this is. And this was in the H method. You hear water? Well, maybe that's somebody's fan. Alright, hold on. In the H and in the A and B function, in the A and B method. Alright, so I got some good functionality going on here, and I gotta remember that I got get tall. So I'm gonna go back, I'm gonna save this. And I'm gonna go back into main, and for my employee, I'm gonna run all three. So my employee that's who's the employee? Bob's the employee, so Bob's the lucky one. So Bob, hello Bob, Bob.getTall. And here's the other little thing. So if you type Bob dot, and you're wondering what can I get, and you know something, it does type in G, because I want to get something. It'll give me all the options, so I can go down here and say I want to get tall. And then I'm going to run Bob dot and wait for the little thing to come out and say, well, what do I want to get here? The next one, get tall with 10. I'm not really using the parameter that I've sent to it, but I've sent it a parameter. And I only have one more, so I'm going to go Bob dot get A and B. So this is going to be 1 and 2. Alright, so you see I've got 3 different method calls that have been overloaded. and they're all from Bob, who's an employee. Here he is here. And you notice that I didn't put the NS logs out here. The ones that NS logs out here are called test. So I'm demonstrating something else to you as well. You have multiple filters. So I've got a filter over here in person, but I didn't do any person. This one's called in person. And I have to remember that one. So let's do a person so I can see that log too. I have a person mo, so I'm going to go mo.getTall. I'm going to grow mo too. So I got 3 inside of employee, and the employee tag that I put in here was called in-emp. Oh, I'm never going to remember that. Here, I'm going to put in here E. I'm going to make my life easier. The tags I put in an employee are called E. And the tags I'm putting in the person are going to be called P. That makes it a little bit easier. P. Oh, there's only one tag in here. Got taller by 1 foot. Inside of person. That's better. In the H method, in employee. In the method, in employee. Alright, that's good enough for me. Alright, so I'm going to go over to the main, and I'm going to make sure I got everything set correctly. And let me just run the sucker. I'm going to run it. It's going to ask me to save it when I run it. It's going to say, I have all these 3 files that have changed. I haven't saved anything, so yes, sure, go ahead and save it. And I'm selecting my VirtualBox emulator. The VirtualBox emulator is going to load up. Oops, it was already loaded with the other one. Let me just make sure. Actually, I'm pretty sure it just loaded up, but let me just load it one more time. Probably going to get double the output now. Now it's loaded up. So if I click on the DDMS, I can go, well, there's my filter from before, test, but what about my E and my P? So then I'm going to add 2 more filters. So I got this one I'm going to call E. You don't have to call the filter name the same as, let me just change it for illustrative purposes. My E, which is the log tag E from employee. And then I've got, I've got really interesting issues there. I'm going to take another tag and call this one P, and this tag is going to be P, and I'm going to see that I'm supposed to have them separate, so I'm going to say, well, that's not exactly what I wanted, so now that I have those tags in there, I'm going to close it back, and I'm going to start it one more time. I'm going to clean out my filter list here, and clean this guy out too. So I got all my messages cleaned out, and let's see if it's going to behave. I'm going to run it again, and let me just make sure I got my tags set correctly. I do. And I'm running. Good, good. So now I have 2 for my filter. That was the Bob and Bob and Mo from Maine, and I have 17 from E. I don't think I got 17 from E. What's wrong with E? Here's E. Why is my filter not working now? I see E right here. In the H method, in the so let's see. 68 from P. So you can see your tag. Actually, your tag is going to show up right here in this tag column. So here's my P's actually, and I'm wondering why my filters aren't working. So let's take a look here. I think I might be using a reserved word actually.
Actually, I think
Yes?
it is taking a common letter, and wherever it will find a P.
You know what? Let me go back. Yeah, you know that's a good point.
In person and was better.
Yeah, let me go back and fix that real quick here. Not such a good idea. How about in emp? That's very unique. Yeah, you're right. It's filtering. The filter is like a wild card. Anything with P in it, anything with E in it. You're right. So this is going to be in emp. But the problem is I can't remember in emp. Okay, you guys have to help me then. In emp. And then we got in person. In person, I can remember in person. Capital I, okay, got it. All right, so now I'm going to run it again. Modify those tags. Modify these tags here. This one is in emp. In emp. And here we have the two emps, and we have here hello. Oops. Uh-oh. Uh-oh. I got the squilly wheel. Uh-oh. Something's gonna fail on me. I hope it's not the recording software. I think it's gonna be Eclipse, actually. Something's not happy. I've got a squilly wheel. It's because I clicked on here too many times, I think. It got confused. Oh, man. Alright, so I'm gonna, hopefully it's Eclipse. Force quit it. Whew. My recording software is still running, that's good. I'm gonna open up Eclipse again. My biggest fear is I get all the way through the lecture and the recording stops. And so I've lost everything. Let's see. Alright, let me go back to the DDMS. Actually, it was the DDMS that failed on me. And all my filters are gone. Nice. So I'm going to call this one test, and it was test. And then, oh, I have a lot of tests, it looks like. And then, let's see. This was a in emp. And that's looking so far so good. And I got in person. Alright, so now you see it in my person object. I put these filters in here, so I got this information that showed up, and then I click on this one, and you see how it actually shows you how many messages there are. I've never used that, actually. I don't really care how many messages there are, but now I have the ones in employees, the ones in persons, the ones in tests. Uh-oh, there we go, the one in test. I thought it was going to fail on me again. Or I have the other things in here as well. So anyway, to kind of conclude that concept, it helps me better troubleshoot and debug where there might be a problem. And I could, possibly do other stuff with this. But what I've shown you is the ability to create an object. So we had two objects here. We had employee, we had person. And person was the base, sometimes called the super, but it's also the sub. A super can be a sub can be a super. This is really called the base object. And then we have employee. An employee is called an extended, it's an inherited object from person. We also have this thing called an abstract class. So all of these classes have implementation in them. One of the things you get in Android is called an abstract class. You don't have that in C++, and you don't have that in the Objective-C either. An abstract class is nothing more than a regular old class, but it has the word abstract in front of it, and it has no implementation. It has just a bunch of method prototypes, or empty messages. So we could add another thing to this and call it an abstract class, and if we did that, we'd implement the abstract class, or excuse me, we would inherit the abstract class. And if we inherited an abstract class, we would have to complete one of the empty abstract methods. So we also have this thing called an interface. An interface is nothing more than an abstract class that is required by contract of implementation to be implemented. So anyway, abstract in concept, let me just go through the definitions for you before I even start with this. Abstract is abstract because it doesn't exist. It's a concept. So we say, if let's say for example we wanted to print, and print is actually a good example of that. I can create an abstract method called print. And if it printed out a person, it would print out a name and an age. And if it printed out an employee, it would print out a name, an age, and an employee ID. And then I would implement Wait, it's like way too loud in here again. Okay, good. I would inherit from this abstract class if I wanted to, and then I could use the base that was given to me, and I could fill in the print method. I'd overload the print method to provide the functionality that was going to be used for an employee versus a person. However, one of the interesting things you get with Java is you have a single line inheritance model. So one class employee only extends person. I can't do this. I can't do comma, extends person, comma, this, comma, that, comma, everything else. It's a one-to-one single line inheritance. So in that particular case, I want to make that print an interface. If I made it an interface, I'd have empty methods that I'd have to fill in by contract. I can implement multiple interfaces. So I could say, and I think we don't have that in here. We just have an extension here. I have the ability to implement interface A, B, C, D, and I separate them out by commas. Adds even more functionality, gives me multiple inheritance. So if you have an abstract method and you have an abstract method inside of an abstract class, inside of a class, the entire class is abstract. So let's go to person for a second here. If I go into person and I make get age abstract, or here, let me just add an abstract method down to the bottom. If I use the word abstract, it goes along with public, abstract, void, I don't know, abstract, void, set, that's not a set. Actually, let me do this. I'm looking at the time, I'm feeling pressured. Let me do this. Let me make this a two-part lecture. Because what I'm going to do, what I'd like to do is show you abstract classes, abstract methods, and I'd like to show you interfaces, because both of them are used heavily in Android. So what I want to do is kind of leave this one alone, because if I start building to it, I'm not going to be able to finish it today, and you'll have an entire week that goes by, and you'll probably forget half of this. I think this is a really good stopping point, actually, for this example. So I'm going to go ahead and save this, stop the video, and kind of take it from there for this one. So this one was called Java Bootcamp. I'll include this underneath the recording, and I will include this in the behaker.com website. And then next week we will do abstraction and interfaces. And if you keep this, so here's the deal. I'm going to take and build from this, because this example would make a really nice abstract example. Because what I'm going to do is I'm going to turn person, put an abstract method in there, make them into an abstract, and show you that, and then add an interface for printing. And then print out, we'll just print it to the text view. We'll put a few more text views on there, maybe a list box or something, and we'll print some more output to it. So what we're building is this kind of test app that we can work with. And it was almost too much to actually give you all of everything about Java in one lecture. So it's probably better to spread it out over two, and I seriously doubt I'm going to finish it in 2 lectures either. But I think it's a better game plan. And then I can take some time and go around and help people. Right now I'll give you some individual help as well. So save this project is what I'm trying to tell you. If the project isn't working for you, download the completed project that I'm going to zip and upload in a few minutes. Do not add it to an existing project. Do not modify it outside of its form. Open up Eclipse. So if I had this project here, and I give you a zip file, you unzip it, put it on your desktop, import it into Eclipse by selecting File, Import. Import it as an existing Android code into Workspace, or project into Workspace. If you select it, I don't have it out there yet. Actually, I can select it from my Workspace folder, from Documents. This is not something I really want to do, because it's going to tell me it's already in there. But it'll put, when you select it from your desktop, it'll put it in the window, select the button, select to import it in. Have it loaded for next time, because then you'll at least have a starting point. And for your homework, play around with it. There's nothing you can do with it that can't be undone. Add some more stuff to the GUI, maybe play around with some of the methods, add some more methods to it, get it to work, get the logs to work if you haven't gotten the logs to work yet, and really kind of study what's going on with it. And I think that'll prepare you a little bit more for what we're going to do next week, which isn't too bad actually. It's pretty easy. So let me stop this video.